Hello and welcome back to my channel. I am Upasana Taneja. In today's video, we are going to study two important topics. First is number of non-isomorphic abelian groups of order n, means up to isomorphism, how many groups exist of order n. N can be prime number or any number, we will see that those cases, okay. And second is how to find non-isomorphic subgroups. Here in first topic we will discuss about non-isomorphic groups, and in second topic we will discuss about non-isomorphic subgroups of a group, okay. So we will see some examples also, because from this topic you can find questions in NET exam, GATE exam and IIT jam. So this topic is very important, and you should clear your concept about this topic. What are non-isomorphic groups, what are abelian groups, and everything. So we will start from the basic. So what are non-isomorphic abelian groups of order n? A group can be of any order, prime, prime square, prime, pq and everything, okay. So when it comes to non-isomorphic abelian groups, so we should know what are isomorphic group. Why are we calling them non-isomorphic? What are isomorphic groups? Suppose you have two groups G and G dash, and you know every group has some operation. Suppose this group has dot and this has star. So we have two groups. If there is 1-1 onto correspondence, there exists 1-1 or onto correspondence between two groups. You can find on my channel homomorphism and isomorphism. I have videos on these topics and I have explained it very properly there, that how to find out isomorphic groups and all everything. So what are isomorphic groups? Two groups which have 1-1 onto correspondence, because if it is a group, that means G and G dash are set. G is a set with respect to this operation and G dash is a set with respect to this operation, okay. So that means if we need 1-1 onto correspondence, that means we need that number of elements in both the groups should be same, because only then there can exist 1-1 onto correspondence between these two groups, okay. So number of elements in G and G dash should be same, okay. Order of G should be equal to order of G dash, then only then there exists 1-1 onto correspondence. Only then two groups will be isomorphic, okay. So if there exists 1-1 onto correspondence, then those groups are isomorphic. But sometimes when we have group of any order, we have many groups of same order, okay, out of which some can be isomorphic to each other and some can be non-isomorphic. So main important question what we get in exams, in MCQs, is that how to find non-isomorphic abelian groups of that order, okay. Suppose if you have group of order of G is n. Suppose we have order of G is n, and then what do you need to do? You need to prime factorization of n, okay. P1 raised to power k2, P2 raised to power k2 up to so on Pn raised to power kn, okay. And then you need to take partition of these powers, not these primes. You need to take partition of these powers. Then number of non-isomorphic abelian groups are P of k1, P of k2 into P of k3 up to so on P of kn. Means you need to take partition and then you need to multiply those partitions, okay. Now the question comes, what are partitions? What is partition? We have discussed in one video that what is partition. So I will discuss in little bit here, that suppose what is partition? Partition means we are partitioning something, we are dividing something. If there are two brothers and they partition, okay, they do partition of their property, then if they divide like this, that one brother will get half and another will also get half, so there will be nothing common in between them. Or suppose one brother is getting 2/3 okay, and one brother is getting 1/3, then there will nothing be common in between them. Okay, so what is partition? If we are partitioning something, union of those elements should be that element total, union should be total, and intersection should be 5. That is partition. Okay, what does that mean? Suppose we have a number 5. How can we partition 5? We can write it as whole number 5 only, or we can write as 4 plus 1. Okay, or we can write as 3 plus 2. Okay, or we can write as 3 plus 1 plus 1. We can do like this. What can we do else? We can do 2 plus 2 plus 1. Okay, we can do 1 plus 1 plus 1 plus 1 plus 1. We can do like this also. 2 plus 1 plus 1 plus 1. So how many ways are there? 1, 2, 3, 4, 5, 6, 7. So we can partition 5 in 7 ways. So that means P of 5 is 7. Remember, if you are partitioning numbers, then partition will be different. And if you are partitioning sets, like if you have 3 elements in a set and you are partitioning it, okay, then it will be different. When I have a video on my channel, and you can see that video, I have discussed about both partitions, partitions of numbers and partitions of sets as well. Okay, so here we are taking partitions of numbers because we are partitioning numbers here. Okay, so P5 is 7. Similarly, on this way you can calculate, like P1 is 1, P2 is 1, P3 is 3, and P4 is 5, and P5 you know 7, and P6 is 11, P7 is 15, P8 is 22, P9 is 30, P10 is 42. Okay, so these are partitions which you can use while calculating these partitions. Okay, or you can find by yourself also. You can check by partitioning the numbers. Okay, so now we come to this topic. Suppose we have order of G is n, then you will prime factorize like this: P1 raised to power k1, P2 raised to power k2, and up to so on. And then you need to partition the powers and multiply them. Suppose, for example, now we will discuss some examples. Okay, this is a question of gate. Question is number of non-isomorphic abelian groups of order 4. So order 24. Okay, so you have order 24. Order of G is 24. So what do you need to do? You need to write it in prime factorization, and you can write it like this: 2 raised to power 3, 3 raised to power 1. Okay, and then number of, what do you need to find this? Number of non-isomorphic abelian groups. What is the formula for that? P of 3 into P of 1. P of 3 means partition of 3. You will partition the powers. Okay, we will partition the powers. P of 3 is 3. Okay, here, and P of 1 is 1. So answer is 3 here. Okay, similarly we will see another example. Example number 2. This is also a question of gate, that up to isomorphism number of abelian groups. You need to calculate number of abelian groups of order 10 raised to power 5. Okay, so order of G is 10 raised to power 5 here. That means you can write it as 2 raised to power 5 into 5 raised to power 5. Okay, because 2 5s are 10, power 5 is equal to, now answer of this is number of non-isomorphic abelian groups. Okay, you can write it as up to isomorphism, or you can write it number of non-isomorphic. Both are same things. Okay, so this will be P5 into P5. That means P5 was 7. 7 into 7, that means 49. So you can try with many orders, like if you have, suppose you have 17 raised to power 6. Okay, you have 19 raised to power 7. Suppose you have these type of groups. So how can you find number of, so suppose like this is a prime number. Okay, this is a prime number. Then what you will do, you don't need to prime factorize this number because this is already a prime. So you just need to see the power, and this will be P of 6. Okay, P of 6 is 11. So answer is 11 here. So these are very easy if you know this trick, that how do you find the number of groups up to isomorphism or number of non-isomorphic group. Now next we come to number of non-isomorphic subgroups, and this is very important topic. So number of non-isomorphic subgroups of a group or subgroups up to isomorphism. So whenever it comes to subgroups, then you always remember about Lagrange theorem. What is Lagrange theorem? Lagrange theorem says that order of subgroups divides order of group. This is Lagrange theorem, that order of subgroup divide order of group. So order of subgroup can only be the divisors of group. If we know the order of group, what is order of group, and we find divisors, so we can have subgroups only of these orders, only of divisors order. Okay, if suppose if order of group is 17. Okay, and the question is find number of non-isomorphic subgroups of a group of order 17. Then you know 17 is a prime number and it has only two divisors, 1 and 17. Okay, that means it has only two non-isomorphic subgroups. A group can have only two subgroups only. Okay, but like if we have a group of order 8, okay, we will discuss in detail this. If we have a group of order 8, we will see divisors of 8. So divisors of 8 are 1, 2, 4, 8. Okay, so for 8 we can have subgroups of order 1, order 2, order 4 and order 8. Okay, but here we are discussing how can we find number of non-isomorphic subgroups. Okay, so if a group which we are discussing that is cyclic, then that can have only cyclic subgroups. Okay, suppose we are discussing about Z8. We will do complete analysis of this. Suppose we are taking Z8. Okay, so what is Z8? Z8 is 0, 1, 2, 3, 4, 5, 6 and 7. This is Z8. Okay, so as you know, Z8 is cyclic. All Zns are cyclic. So it will have only cyclic subgroups. Okay, what are cyclic subgroups? Cyclic subgroups are those subgroups which are generated by elements of any group. If we will generate subgroups from 0, 1, 2, 3, 4, 5, 6, 7, then we will get cyclic subgroups of Z8. Okay, all these are cyclic subgroups, but out of these, some will be isomorphic to each other and some will be non-isomorphic. So the question is to find number of non-isomorphic subgroups. Okay, and we have one short trick also. After doing this, I will give you a short trick also for this. Okay, so first of all, we should know what are generators of a cyclic groups. It is group of order 8. So its generators are phi 8. Generators are phi 8. Phi 8 means phi 8. Those elements 1, 3, 5, 7. These are generators of phi 8. Z8. Okay, so these elements, one will generate Z8. If we will operate one by one time, two times, we will get 3 up to so on, we will get a full Z8. Okay, and 3 will also generate Z8, 5 will also generate Z8, and 7 will also generate Z8. So these all are isomorphic to each other. 1, 3, 5, 7. These are isomorphic to each other. Okay. Now the question comes, 0 will also generate a group. If you will operate 0, you will get 0 only. Okay. You will add, because Z8 is a group with respect to plus addition modulo 8. Okay. You will add 0, 0, 0 and divide by 8. You will get remainder 0 only. Then you will which group you will get here? You will operate 2 one time, divide by 8, remainder 2. 2 times 4, 3 times 6 and divide by 8, remainder 6. 4 times 8, divide by 8, remainder 0. So this is the group. Okay. When you will operate 4 one time, 2 times, you will get 0. Okay. Similarly, we have 6 here. You will operate one time, 6. 2 times, you will get 4. 6, 6, 4. 6 plus 6, 12, divide by 8, remainder is 4. 6 plus 6 plus 3, 18, divide by 8, remainder is 2. And 6 4s are 24, divide by 8, remainder is 0. Okay. So as you can see, we got this group, this is unique and this is same. So 1 we will count this. We will not count this, this and this. We count this 1. Okay, because these are all isomorphic to each other. And this is isomorphic to 6. So 1 is this and 1 is this. So we got 4 generated by 0, generated by 1, 3, 5, 7. Okay, generated by 4 and generated by, you can say, 2 and 6. So these 4 were non-isomorphic subgroups of Z8. Because we were talking about Z8, Z8 was cyclic. These were 4 non-isomorphic subgroups. These were not isomorphic to each other. And this is equivalent to Z1. Okay, because order of this group is 1. So this is isomorphic to Z1. Okay, order of this group is, this is isomorphic to Z8 only. Order of this group is 4. This is isomorphic to Z4. Order of this group is 2. This is isomorphic to Z2. So Z8 has 4 subgroups, or you can say 4 non-isomorphic subgroups. Which are those subgroups? Those are Z1, Z2, Z4, Z8. These were, and you know, these were divisors of Z8 because Z8 was cyclic. So these divisors will be its subgroups. Okay, and now we have one short trick as well. What is that short trick? Number of non-isomorphic subgroups of a cyclic group of order n. If the group is cyclic, if a cyclic group of order n is equal to tau n. Tau n. What is tau function? Tau function is whenever you have a number n and you do its prime factorization, p raised to power a, q raised to power b, r raised to power c up to so on, where p, q, r are primes, then what do you need? Tau n is a plus 1 means powers. A plus 1, b plus 1, c plus 1 and up to so on. So here we were having tau of 8 because the order of group was 8. Z8 is cyclic. We know that Z8 is cyclic and order of group is 8. So tau 8 will be 8 is equal to 2 raised to power 3. So tau 8 will be 3 plus 1. That means 4. So we have 4 non-isomorphic subgroups of order of a cyclic group of order 8 that has 4 non-isomorphic subgroups. You can find by this also, complete analysis of Z8, and you can calculate by a short trick also. If you need to show for clearing your concept, you can see this, that what are non-isomorphic subgroups and how do we find them, what if a group is cyclic, and how do we find those non-isomorphic subgroups. Okay, so I hope you got it, what are non-isomorphic groups and what are non-isomorphic subgroups, and what are short tricks to find those non-isomorphic groups and subgroups. We discussed that also. So if you are getting it, then please subscribe to my channel. Please follow me on Instagram and Telegram. Also join channel Dr. Upasana Taneja, and please keep watching. Thank you so much.